Let's see. Can you hear me now? Can you hear me now? Okay, well, y'all missed the world's best intro. I am so sorry about that. John here, staff software engineer, lead maintainer of Ladderly.io, the open source educational platform where you can learn to code, land your next programming role, and grow your professional network. Thank you. Shout out to the Neverworld. Thanks for letting me know. Throw some likes on the video so the algorithm will send it around. I might have foot gunned myself. Jabayu, gentleman caller, thanks for being here and thanks for noting on the TikTok side. Make sure to follow me on another platform as TikTok will be shutting down this weekend. Okay, and so what we're doing here is we're going over the jobs report. So programming has had a hard couple years, tech has had a hard couple years, but what's often missed in the social narrative is that actually the entire economy has had a hard couple years. So before we say that tech jobs are out, we need to compare it to all other industries. And it turns out that all industries are down 8.6% year over year, but tech is up 14% year over year, using very conservative estimation off of TrueUp. So we got this conservative estimate because we looked at trying to slice on January 1st, but there's no particular data for the first. So we look to the left and the right, and we take the highest old and the least new, and that will give us the most pessimistic or conservative estimate of growth. Okay, so we go 185, and let's round that up to 186, and then we look around January 1st, 2025, we see the third at 212.5, we'll even round it down, and then that's the lower number among these two. So we take the lower current number and the higher old number. This should be the most pessimistic or conservative. Even on this pessimistic estimate, we're looking at 13.9% or about 14% growth. Okay? So basically the narrative is wrong, that tech is like doomed, like we shouldn't be advocating tech jobs. No, it's actually the main growth sector. And there are economic reasons for this we could get into. You can check out the Cobb-Douglas equation. Okay, so A, which represents technological progress, is unique compared to capital accumulation markets and labor markets because it doesn't exhibit diminishing returns. This is one of the reasons the tech industry is unique, also because it's a cross-cutting industry. If you look at the economy sector by sector, you'll notice some of the top sectors for employment include healthcare and education. Technology cuts across all of these. So health tech is a field, ed tech is a field. And so by getting into technology, you can actually access jobs across all sectors of the economy. And this is another reason alongside and harmonizes with the Cobb-Douglas equation, showing that we should expect most growth and in particular job count in this sector. And that is borne out despite the social narrative that you hear online. Okay, so consult the data over the social narrative, right? And so tech jobs are down 55% from peak. That's true, bummer, but it's also up over 30% for low. And we're on a steady uptrend. And the year over year is way better than all other industries. Okay, so this is the data we've accumulated so far, but we're not even done yet. Scroll down. Artificial intelligence, according to the Indeed data, is one of those sectors that is growing quickly. It's growing relatively quickly. Okay, so you could say 2.6% is like not super quick, but relative to other options on the table, it's doing rather well. AI in particular, and AI is programming. You need to know Python to access AI. So now we're going to start to ask the question, okay, tech is going up, but if I'm a job candidate, where in tech is it going up? What job families and job titles should I be targeting? And then remote work is in a new normal, which is above where it was previously. So that's great. And wages are like, you know, you can look at them. It's about where it was. It's about where it was. We'll see where it goes from here. It's about where it was before the whole weird thing that happened with the cash infusion from COVID. Okay. So, here's another positive thing. The major layoffs are down. Okay. So in the news lately that Meta is having layoffs, that's true. But they are the exception, not the rule. By and large, you can see that layoffs have been down since since after August, basically, of last year. Okay. So jobs are increasing. If we go to big tech hiring, the big tech companies are hiring. Layoff is doing that. Meta is doing that classic thing where they lay off and then they go hire. And that the idea is they can cut the low performers and bring in some high performers. So it's not like even Meta with the layoffs is not shrinking. They're just replacing their low performers. And that's been controversial in the news that they've been actually explicit that they are firing low performers. So that's their own words. The fact of the matter is they have over 1,000 open jobs. All right. So these are tech jobs, right? Hundreds of thousands of tech jobs. Frankly, even if it was on the downtrend, you as an individual can likely still land a job with proper technique because there's hundreds of thousands of jobs open. And even if that open job is lower than it was in the past, there's still hundreds of thousands of them. So 1% of 1% chance you can still do it. But let's keep dissecting this. So what particular skills or job titles should we be looking at? So let's keep this number in mind, 200,000, thereabout. Well, if we look for Python, there's over 60,000 with this one skill keyword, specifically in the United States. Okay, over 60,000. Another thing that I want to call out here, big tech gets a lot of attention, but the majority of jobs are not in big tech. So other private tech companies are the largest group of, and this has always been the case, but I guess we're doing an overview, so I'll just refresh. There's tier 1, 2, and 3. Tier 1 is like the most prestigious, they pay the most, but they're also the smallest group. Tiers 2 and 3 are easier to get into, and there's also more jobs there. So yes, it's true. It's really hard to get a tier 1 job. I've gotten tier 1 offers myself, and it wasn't easy. And I am not even sure that I recommend most people target that. I think getting a foothold in tier 2 or 3 and then working up to tier 1 is a more feasible strategy. But the point is, there's lots of jobs, and they're not just these FANG companies. The fact that Meta is having a layoff shouldn't matter much to you. It's really a drop in the bucket of the ocean of tech jobs. Okay, that's the point there. So Python over 60,000 with this one skill keyword. What about SQL? So if we think about there's basically individual contributor jobs and non-individual contributor jobs. Okay, that's one of the big divides of job family. So an individual contributor might be an engineer or a researcher. So they're the data family of roles. And then there's the non-data family of roles. Software engineer, front end, back end, full stack, mobile developer. These are engineering roles, which is, we're going to see basically it's the primary. So there's engineering roles, and then there's data jobs, and then there are managers, and then there are engineering, people managers, and then product managers. So these are all candidates, and we're investigating when we dissect that 200,000, where are they? And we're seeing 60,000, 50,000. What about web developer, HTML, CSS, JavaScript, TypeScript? Well, there's another 50,000, okay? So roughly equivalent to SQL. Now, a couple interesting notes that are different than in the past. SQL and Python are both higher than this collection of technologies, and maybe I can say or React. Let's see if that changes the calculus here. Barely edges out SQL. So when we think about the return on investment to learning a skill, Latterly has traditionally advocated full stack web development, which is going to be this series of skills. And SQL is a gray area because a full stack developer knows SQL, but there's also this very different job family, data analysts, business analysts, and so on, that SQL is their primary skill. As opposed to the engineer, it's a secondary skill. So I'll call this a wash, basically. It looks like you can access about as many jobs. We're taking a time slice now, but if I check it next week, there could be fluctuations. So I'm going to call them approximately equal. You can learn all these web development skills, or you can just learn SQL, is how it seems. But there's so many gotchas, aren't there? Look at this number 1, number 2, number 3 job here. All of these top jobs that say SQL are actually software development and software engineering jobs, including a junior job. So when I'm dispelling these toxic narratives, the first one is that the tech market is bad right now. Actually, it's growing faster than other markets. Two is that software development is out. Actually, it's not. And the another is that there are no early career jobs specifically. Like, fine, maybe there's all these jobs, but they're reserved for seniors. Well, let's go back and look more in the true up data. Remember, these are the people that said 200,000 plus jobs. What do we notice? Job categories, job families, engineering is up at the top, specifically software, not hardware. Hardware engineering is way down there. I'm sometimes asked, what about hardware versus software engineering? There's more than a 10x benefit to going software engineer in this data set. Okay? And then where are the data roles? Here's data analytics, data science. And isn't that interesting? We're splitting up data analytics and data science. It's almost like when you consider the particular jobs, you shouldn't group all Python roles together. And this is the problem that's often missed when people say that you should learn Python. They are missing the fact that Python actually is used in very different job families. In fact, it's also used in engineering. So Python will help you access some of the engineering roles and some of these other roles. But if you add these up together, you're looking at like 19, 20. It's still more than double to go for software engineering. So software engineering is still king. That's the next big takeaway. Tap like if you got it. Chris Jones, welcome in. Shinra, thanks. Over 300 likes on TikTok. Thanks for being here. Consider adding some more likes. That'll help the algorithm send it around. Okay, so next takeaway is that software engineering is still king. Now, that's when we look at all of the data posted. What if we just go for the past month? Software engineering is still king. But wait, isn't this at odds with the labs data? The labs data showed us that AI was skyrocketing. In fact, we can drill into the AI data. We can see AI job postings. This one seems to be growing really quick. And then we can also look at generative AI postings. And let's look at the US. And this thing is really taking off, isn't it? So generative AI is, this is another misconception in the social narrative. The thesis is AI, and in particular generative AI, is growing faster than almost any other role. And that's true. But the problem is you get a large growth rate precisely by starting at a small number. There was like 0 jobs for generative AI in 2021. Literally 0.0. Are you seeing this? I scroll my mouse along, it says 0.0. So when you go, and now here we get to, oh, there's something wrong with that thumbnail, huh? Oh, okay, now it says .1. I guess it's still rounding down to 0. Okay, so when is it big enough that we can round down to 0.1? It's over here. So when you go from 0.1 to 0.2, you're doubling the jobs, but there's a low job count. So as a job search candidate, I want to access a pool of a large job count, not just a growth rate. So software engineering has a smaller job growth rate, and indeed the growth rate is down, but it's still positive, and it's on top of over 100,000 jobs. So a small growth rate is many jobs. Does that make sense? Matthew says, what site is this? We're consulting multiple sites. We're not building a thesis off of one site. But this is going to be data.indeed.com. And also trueup.io are the main ones we've consulted so far. So another key takeaway here, don't look at the growth rate as a job candidate. Maybe if you're an investor, growth rate is really cool because growth rate goes with return on investment, right? So if you're investing cash, Gen AI looks like good stuff. But if you're a job candidate, you want to target a pool of many jobs, software engineering is still king. Even if the growth rate is smaller, it's a small growth rate precisely because it's already at a large quantity. So getting another 1,000 jobs doesn't make much of a difference. Does that make sense? Okay, so chat asked, is Laravel worth it to learn? Laravel's a PHP technology. Stay with me. We're going to end up talking. We're going to drill into the skills that you need to know this year. TLDR, the answer is no. PHP is not on top. It's not on top. Okay. And the takeaway from looking at past month versus all, is that actually there's there's not a conflict with the Indeed AI tracker. You just need to know how to understand growth rate versus level effects. So when I look at all posts, data analytics is further down, and we can look at the ratio. So we'll look here at the ratio about 20 to about 50. Okay, so it's about 5 to 2 for engineering. Now let's look over the past month. Now we're looking data analytics, and where's data science? Data analytics here, data science here, another 4, so 9, let's call it 10. So it's about 2 to 1 instead of 5 to 2. So the AI in analytics and data roles are catching up. A 2 to 1 win for engineering is a smaller win than a 5 to 2 win. Do you see how they're actually harmonized? The data is actually harmonized if you can interpret it properly. So yes, AI is growing quicker, but it's coming from way smaller number, so that it's still like 2 to 1 favoring engineering, software engineering in particular, not hardware engineering. Okay? Another thing that's really important to think about in this data is that software engineering here is underrepresented. 5 to 2 ratio, and it's still underrepresented because if we look at sales engineering, that will bring it up from 5 to 6, roughly. So sales engineering, these are a particular group of software engineers that work closely with salespeople, basically. So they might run a demo for a client, show how to use a tool. They might even take client feedback requests and try to implement those if possible. So this is still, there are still software engineering skills in this sales engineering job family. And then research is interesting, that you could call that a data-related field as well, but it's quite small. It's talked about a lot. It's a high prestige field. Applied AI researcher, things like this. It's a largely talked about field, but it's actually a really small field. There's not a lot of these jobs, and it's not something that's easy to dive directly into. These roles, as well as data science roles, will tend to require or strongly prefer graduate degrees. Web development is still one of the easiest to break into for non-traditional, like career switchers. Okay, and one other thing that I want to mention here on the Gen AI, so if you think data is cool, if you think AI is cool, Gen AI, if you look at these jobs, are actually very often engineering roles. These are software engineers using Gen AI. So an example of Gen AI would be the Gemini API. And this is a way that you use generative AI, but the contributors who are integrating generative AI are software engineers. How do I know this? Hi, my name's John. I'm a staff software engineer in generative AI. And I don't use very much SQL. I use a lot of Python, but I don't use very much SQL. And how am I using Python as a programmer? I'm still coding. We need to teach people to code still. Okay? So there's some of the takeaways. This generative AI job family should not be considered other than software engineering. Rather, it's a specialization of software engineering, as is data engineering. Another really high growth field that's really sexy, gets a lot of headlines these days. Data engineering is actually a specialization of software engineering. So if you want to learn data engineering, you're best off to start with software engineering, and then you can specialize into it. It's like AI integration only with Gemini. There's lots of language models, ChatGPT, OpenAI. Gemini SDK is one that I like to use because they have a generous free tier. So makes really great portfolio projects, pretty easy to work with, good developer experience. But it's not the only one. All of the major providers, Anthropic, Claude, Sonnet, these are all generative AI technologies. How do we use these? We use them as a software engineer. And sometimes we've heard this new job title, AI engineer. But an AI engineer is a software engineer. It's a special form of a software engineer. Okay, so if I look up AI engineer, there's this concept of an AI trainer, which is very different. This is really a part-time role. And it's not super lucrative, $40 an hour. An AI trainer is someone who is providing training data to the AI. So if you skip, and there's not really many AI trainer roles. So this is a new role, but you can see only 500 plus jobs when we're talking about 50,000 plus jobs, okay? So I'm not going to advise you to chart your career to become an AI trainer. It's kind of an interesting side gig maybe, but this is not like a job that you should be targeting. Okay, so let's go back to AI engineer, and then when we search for this, let's ignore the AI trainer results. Okay, so 10,000 plus jobs, it's on the same order of magnitude of Python. That's interesting. But let's look at some of these. So NLP engineer, LLM specialist. What is this role? Let's read about the job description. So they're not going to use Gemini in this case. They're not going to use Sonnet. They're not going to use OpenAI. They're using Llama 3, which is a particular language model. And if you read through the tasks and read through the skills, they need to know Python. They need to know PyTorch. They are programming. These people are programming. So again, this is and it even has specialist in the title. This is a specialization of software engineering. Okay? And then we can scroll down further, senior development technology engineer in AI. Nice paycheck here, goes up to over 300. You can see they're going to prefer a master's degree. Maybe you can get by without it if you have adequate experience. Yeah, so they're going to want 8+ years of experience anyway. But experience in what? Experience programming. Experience programming. Okay, so these AI engineer roles are specialty programming roles. So how do I decide which to pick among these? Okay, the first thing, I need to do two different things. First, I need to split Python by job family, because as a candidate, I'm going to be targeting job families. And so once we reassess and go for job family, we're doing software engineering. We're doing software engineering. Now, to approach software engineering, I can use JavaScript or Python or TypeScript, which is just JavaScript with types. So which should I choose? And this is this is the cheat code. Okay, this is the big cheat code. The answer is you brute force it. Oh, and by the way, product manager doesn't explain most of the jobs. It doesn't explain most of the jobs. So here is the grand reveal. And also engineering manager doesn't explain most of the jobs. So engineering manager, product manager, this is about 30K of, remember, that 200 plus. Okay, so the way that I brute force it is that I just learn all of them. So here is a full stack developer who knows SQL. A full stack developer who knows SQL, and this is like basically a competent full stack developer. You would be like, you might be able to get a full stack engineering role without knowing SQL, but that would be, you would be under the expected bar of skill set, okay? So once you have a real full stack developer who knows all React and SQL, over 100,000 jobs, now we're in a new order of magnitude, and we have Python well beat. We have Python well beat. But you don't need to make them antagonistic. You can just learn Python, all right? And then the problem totally goes away. Because what will give you access to more jobs? If you know Python or if you're a full stack developer? Learn both. Learn both. Learn both. So don't underestimate the brute force technique. And now we get the grand reveal, 130,000 plus. This is the majority of tech jobs now. Do you see that? We're biasing this analysis towards the United States. Okay, so if you live in another country, this may vary by country, but in the United States, the majority of tech jobs are software engineering roles, and then software engineering, there's so many programming languages. PHP came up in the chat. So PHP, Ruby is somewhat popular. Not as popular as these two main languages. Kotlin, Java. There's so many different programming languages, like where do you go? The answer is that this accounts for the majority of all tech roles, let alone software engineering roles. So all of those other languages are peripheral. C, C++. These are all C#. These are all a fraction of tech roles and really a minority of software engineering roles. The majority of software engineering roles you'll be able to access if you know these skills, okay? So in the past, I've said learn React, not Python. And in 2025, I'm saying learn React and Python. learn React and Python. This seems like it will be just creating so much work for you, but there's something that's available now that wasn't available in the past, and that is AI-driven development, AI-driven learning. So using a language model to help expedite your learning. And I think that you can learn all of these in the following time frame, 3 to 24 months, depending on if you want to do this full-time or part-time. Frank says Kotlin and Java is just modernizing ancient code. Yep, a lot of it is. The Neverworld says poor PHP. Yeah, poor PHP. I mean, if you think about what is the most popular PHP application, it's WordPress. And if you're into tech news and if you know what's going on with WordPress, WordPress has been in the garbage lately. There was, yeah, WordPress issues. It's going to give me like a status report. Yeah, there's been like a ton of drama between WordPress and WordPress Engine, one of the major, I don't know, stakeholders in the WordPress ecosystem. So now is not the time to get into PHP. It's really not. Not that it even was a great choice historically, but it's just really not a great choice now. Okay. So, and I'll call out one other thing, and then I'll give you how many of these? I'll give you 5 killer projects that are going to be special portfolio projects that'll help you stand out in 2025. Before I get into that, I want to dispel the early career myth. So let's go to, these jobs and then the level of seniority. Entry and mid-level is the largest group. Do you see that? 50, 65, 70, okay? It's actually larger than all other groups combined. It's larger than all other groups combined. So the market is back, the layoffs are down, despite what the social narrative is, despite what the news is talking about meta layoffs. Yeah, but it's a drop in the bucket, okay? The market is actually back. It's growing faster than other industries. Software engineering is still on top, and early career roles are available. Early career roles are available. The big mistake that I see when I work with individuals here, and I am coaching them on how to go about their job search, the big mistake that I see is that they identify as junior engineers. I'm only applying to junior engineering roles, or I'm only applying to internships. Huge mistake. You see, TrueUp.io has grouped entry and mid-level together. And it would be interesting to break those apart, wouldn't it? But you don't need to break them apart. If you have a portfolio of 2, 3, 4, 5 projects, you are a software engineer. You are a software developer. You're not just a junior developer. And if you go into the job posts on Indeed.com or wherever, the reason that they've grouped these is actually quite natural. The reason that they've grouped these is because many early career roles do not even title the job post with junior or early career or anything like that. Some do, but a lot of them will just say software engineer. And if you look at the job description, they just don't have any years of experience required. It's just not a requirement. Or it might say like 6 months or 1 year. You get access to a lot more jobs at the 2-year mark. It's true. But reflect on this. 3 to 24 month roadmap. Now you have 2 years of experience if you start your portfolio day 1. Okay, so this is another big mistake, is that I see software engineers are not committing to GitHub. Committing to GitHub has gotten like a bad rap. Like, I shouldn't need to commit to GitHub. It's true, if you're a senior engineer with 5+ years of experience, no one really cares to look at your GitHub anymore. There's some exceptions to that, but by and large, that's true. If you're early career, you absolutely should be committing to GitHub because it's a proof point that you have these months or years of experience. So start contributing to your GitHub day 1, get the little green square, and then by the time you really have just learned and you're just going on the job search, you already have, in most cases, 6+ months of experience. The person who can get through all of this in 3 months is an exceptional person. Let's be clear. This is not realistic for most people. 3 months would be if you're smart, if you're full-time and you're smart, then you can get your portfolio going in 3 months, and I think that's a happy case. I think that's like a positive edge case. And these sorts of people can probably pass the interview anyway. maybe they need one more month of interview prep beyond learning the skills, then they need to actually go interview prep. And yes, they will face some friction in that period between the 3 and 4 month mark and then up to the 6 month mark. They will face some friction, which is like, you don't even have 6 months of experience. Like, why are we considering you? Once you hit that 6 month mark, it's going to be notably easier. And then you can do things like the following. Once you get to the 9 month mark, you can rework your talking points and call it approximately 1 year or about 1 year. Say, I have about a year of experience. And it's true. Oh, you only have 9 or 10 months. No one is splitting hairs like that. They are going to accept it when you say you have about, it's like rounding. They're going to accept that. Okay, he's got about a year of experience. Let's give him the interview. And then it's down to, how do you perform in that interview? How does your portfolio look? How does your resume look? How does your LinkedIn look? And if you've been creating content, you've been growing a social network of warm leads, and these people can even advocate for you. These people can advocate for you. All right? So I think I've gotten through the major talking points. Yeah, that's basically what I recommend now. I will recommend, just as I always have, that you start with web development because it's easy to get into, intuitive to learn. You can build portfolios that are visually interesting. And then I will recommend that if you are still in the job search, I want you to split your time. And at this point, I think it's worth it. In the past, I would have said, don't even worry about Python, just go all in on the job search. Hit those coding interviews with JavaScript, just go with JavaScript and you can get that role and you can learn Python later after you're employed. These days, I'm willing to split that. I will say, once you start interviewing, split your time between job prep and continued education. And in that continued education, I would like you to get TypeScript, SQL, and then Python. And I think it's worth it. I think it's worth the additional time that it takes, particularly considering that that additional time is shrunk now that we can learn more quickly with language models. And now that Python has a higher return on investment because of this AI boom. Okay, and so what about these projects? And we have a question in the chat. What is EDA? Oh my God, bro. It means exploratory data analysis. And EDA, and Google is your friend. An exploratory data analysis is kind of like a project. You're building a project. And the project that you're building is you're doing what data analysts do. You're doing an exploratory data analysis. You're going to have some data set that you extract insights from. So let me go through these recommended projects and then I'll give you a more concrete example. Here are some killer projects that are going to help you stand out. Damn, I don't think you can see the TikTok chat. I can. What's the question? Now they say professional experience. No, they've always said that. They've always said that. And you need to be a strong advocate for yourself and say that my open source contributions count as professional experience. My open source contributions count. You are a real developer. And let's talk about the projects because there are ways that you can harden and reinforce this case that you're making. One is by acquiring real users. Acquiring real users. That will help this be a case that it's professional experience. Although you shouldn't let them put you down even in your early months. But as time goes on, if you're creating content and if you're building projects that have like a login system, you'll be able to acquire real users. And it's really hard for people to push back and say that's not a real app at that point. It's like, dude, I have real users. Maybe I'm even making real money. And particularly if you're creating content, you're going to be able to acquire more users that way. Okay? So let's get into these projects. There's a bunch of projects that you can do. Latterly, historically recommends starting with a blog because everyone knows what a blog is. It's easy to build. It's easy to communicate. It's easy to use. And you can customize it to yourself so that you won't have a cookie cutter website. It's your blog. You're writing your own blog articles. And the key is to actually use it and put your own learnings there. And this goes along with content creation. And now it's unique to you. It's unique to you. But in 2025, we can do some additional things that are really going to help you stand out. One is data visualization. So you can visualize data with a library like D3JS, which will allow you to make all sorts of visualizations in your website, you see here we're looking at a website. How do I get this cool graphic? They're actually using D3.js here on the D3 website. Okay, so this is visually stunning and interesting. This is a really cool portfolio piece. But you can also do data visualization with Python. Something like, so Python data visualization. Like Seaborn. Yeah, Seaborn is great. Or Matplotlib. I like Seaborn more. Plotly, if you want to do a graph in particular, but I like Seaborn a lot. And so let's look at some Seaborn examples. And what you can do here, so here's what you can do is you can make a data visualization with D3 and then replicate it in Seaborn. And you can literally have the portfolio that's like, why did you make this? I was learning Python. I was hardening my Python skill by reproducing a visualization from D3 into Seaborn, or vice versa. So this data visualization skill is something that will help you stand out. A lot of people don't have a portfolio at all. And then a lot of people who have a portfolio, it's boring. It's boring and it doesn't look cool. When we want to access data roles, being able to visualize the data really helps you stand out. As a data analyst, data scientist, data engineer, it's going to help you in any of these. And it helps you as a web developer. So the cool thing here is that by learning Python, you're actually a better software engineer. And by learning full stack web development, you're actually a better data analyst. That's another main takeaway. If you are a data analyst, you only learn SQL and Python, let's say. You're going to make your portfolio much better if you can create data visualizations and put them on a website for people to go look at. So really, these skills, it's not like you're struggling to get all the way down to Python like this is the golden land or something. You can start interviewing up here, but every step of the way, you're becoming a better software engineer. And you can also do it in reverse if you really want to. I'm not going to recommend that, but you could go Python and then SQL, and then I would probably go JavaScript before TypeScript either way. But even if you want to go directly to data, building your data portfolio, having web development skills will help you make a data portfolio. So they go together. So what I'm trying to highlight is the overlap on those roles and the fact that these skills go together, as opposed to what you often hear in the social narrative is that these are really different. No, actually, it's like 80-20. Like there's a lot of overlap, and then there are some differences. Dude Dookie says, how about front-end engineer? Hey, I got news for you. Data visualization with D3 is front-end engineering. It is front-end engineering. But what I would tell you to do, Dookie, is once you do that, go learn the additional skills too, because here's the bad news. I need to give you a reality check. If you're restricting yourself to front-end developer, you're whoa, that says front. If you're restricting yourself to front-end developer, you're 2 orders of magnitude smaller. This is a niche at this point. Does this guy do one-on-one coaching? Yep. Yeah, try to send me a DM, but TikTok is shutting down. So y'all should make sure to follow me on other platforms. Check my bio. And you can DM me in any of the platforms in my bio. So front-end development is a fine stepping stone, but I really encourage you, do not stop there. You will be at 10% of your potential, okay? You'll be at 10% of your potential if you restrict yourself to front-end development. And there's no reason to do that, because to become a front-end developer, you need HTML, CSS, and JavaScript. You're probably going to learn React and TypeScript to be a good front-end developer. But by the time you have that, why don't you just take your TypeScript over to the server side, and now you're a back-end developer, a full-stack developer. In addition to a front-end developer, you can access many more job titles. Many more job titles. And again, once you have the data visualization skill as a web developer in JavaScript, a lot of that will be transferable to data visualization in Python. And so we've just gone through how much value there is in learning Python. And it's also going to help you in the interview. So LeetCode interviews, data structures and algorithms. Learning abstract data structures is more intuitive when you have multiple languages. So in JavaScript, I will have an object, and in Python, I will have a dictionary. But the abstract data structure that supports both of them is a hash map. So learning about abstract data structures is actually easier once you're dealing with multiple languages. And then at the interview, actually coding a LeetCode answer is generally easier in Python. So these things are going together. So it's possible to get a job with a front-end developer. I'm not going to say you can't do it. I'm just going to say I think that is a poor investment of your time. Once you hit this React here, I want you to start interviewing, and I want this to be 50-50 with continued education. Okay? So we all agree you want those front-end development skills. We all agree you want to get up to here, right? But I think going 50-50 and continuing with these is a way better investment than just going 100% in right here. That's what I'm advocating to you. On average, how long would it take to go from 0 to job interview? So again, I've said that I think this range you can do in 3 to 24 months, and I think that'll account for over 80% of people who try to do this. If you want me to do just an average, it's really important to distinguish between part-time and full-time. Yeah, so I guess I would go right down the middle there. So maybe 14 months, and but that's a weird thing to say because that's saying that you're half part-time, half full-time. Almost no one really does that, right? So I think the smarter way to think about it would be, yeah, I think 14, hold on, how am I doing this math? This should be the part-time. Yeah, so I think 14 months would be average if you're part-time. I think that's right. And then if you're full-time, so much of this depends on if you get a good curriculum or not. If you're following the Latterly roadmap, then I think you're looking at, and did you say till hired or till interviewing starts? Let me double check that. To job interview. Okay, to get your first job interview, I think you can get your first job interview if you're doing full-time with a good curriculum. I think you can get your first interview in 6 months. Now, getting the interview and passing the interview are two different things, right? But I think you can get that first interview in 6 months. Okay, so we talked about data visualization. What about in-context learning? Full stack with Python with Gen AI. So let's imagine that you've gone through the Latterly traditional curriculum and you've gotten this far, and that is a full stack application. A full stack application with a database, and you have blog articles. That's the traditional recommendation. Now I want you to add the Gemini API that I talked about earlier, which you can use for free in your portfolio. I want you to add it, and I want you to use Python to integrate Gemini API. And now you have your own ChatGPT, your own chat application, your own UI, and your users can use that feature to summarize your blog articles, to search for a blog article related to a topic that they ask about in natural language, or even to develop a recommendation system. What article are they probably going to like? You can have this based on a chat interface, or you can just collect background data about the articles that they're spending more watch time on, or the articles that they're liking and disliking, and you can infer, so this is inference, this is a data science thing, inference. You can infer the next article that they're most likely to either read, like they'll actually read the whole thing, or they'll give it a thumbs up, something like that. So you can recommend an article. This is really going to help you stand out. This is like machine learning stuff. Really, you're really going to stand out if you can do this. And then exploratory data analyses. And there's two ways to do this. One is you can do a blog analysis with real data. So in this case, you've got real users who are reading articles. You're looking at your Google Analytics. You're seeing where's the watch time spent. You're seeing what articles do they just kind of click out of really quickly versus what articles get a lot of traction. I can tell you on my website, on the Latterly blog, I've done this myself, right? So on the Latterly blog, people love the LeetCode article. People love this Latterly LeetCode number 3. And they like some other ones. And then there's others that they just ignore. Like almost no one reads the essentials of HTML. Anyway, I'll just leave that where it is. Okay, so you can figure out, these are insights. You can figure out the kinds of articles that your audience prefers. That is an exploratory data analysis result. And in a commercial application, what you would do with that is the data analyst would go, hey, I looked at our data for the blog, and like people like LeetCode articles and they don't like HTML articles. So I'm recommending to you that if you want to drive traffic to your site, if you want to increase SEO, if you want to increase signups, make more content around LeetCode. You see how that's a business insight. That's a business insight. And you can do that with real data, and then you can generate a behavioral anecdote, a behavioral interview story and a result and say, hey, I found this insight, I applied it, I actually updated the content on my blog, and I was able to see this change in traffic, some percent in traffic. So you're really doing the full life cycle of professional data analysis and engineering at that point. You can also do a synthetic EDA. The way this works is maybe you don't have real users. Maybe you don't have real users. That's okay. You can use the ChatGPT language model and ask it to create synthetic data set. Let's just pretend I had users. So ChatGPT act as a website user and generate like views and watch time and stuff like that. So it's a synthetic or fake or fictional data set, but you can still do a real analysis on the fake data set. So you can still put in your portfolio that you did an exploratory data analysis, upload to GitHub, upload the synthetic data set, upload your report. So upload your SQL scripts, whatever you do, your Python scripts. You're extracting, you might be doing a regression, you might be doing a cluster analysis, whatever logic that you're doing, you might just be looking at mean, median, mode kind of thing, like basic descriptive statistics, to extract your insights and write up a little report. It doesn't have to be long. You can do a one-pager, right? You don't get bonus points for having 100 pages in the business world. So you do your little one-pager, you write it up, and now you have a GitHub repo that has a synthetic data set, some scripts, and then like a nice README. And that is a data analyst portfolio piece. That's a synthetic exploratory data analysis. And then I already talked about the next article recommendation system. Again, you can do this with real data, dog fooding your own website. So like you build the website and then you use it to get really improve your actual users in the real world. That's exactly what businesses do. Or you can do it with synthetic data too. Just to kind of demonstrate that I know how to build a recommendation system. Even though I built it on synthetic data, someone can go look at the code and go, oh, like, okay, he did build a recommendation system. It's fictional data, but that's okay. The point of this GitHub repository, this portfolio piece, is just to show that I can build a recommendation system. And both of those will help you stand out in this market. Especially as an early career person, do not feel bad for using synthetic data. It's still going to help you stand out. All right, let me look through the chat if I have any more questions. In my data interview, they asked me if I knew multivariable calculus. Yeah, look, this is just standard job search practice. You're gonna get some bad apples, okay? So the way to solve that, there's two things that you can do. The first thing that you can do is just don't take that job and apply more places. So you need to be able to distinguish between one-off weird situations and then patterns. Now, if you're, I don't know like what country you're applying for, maybe it's a different country, maybe that's the norm wherever you're at. If you notice a pattern, if you get like 3 different interviews where they're asking you this kind of question, you keep fumbling, now it's time to actually go back and backfill your skill. So I don't personally expect, you also say in my data interview. So I'm curious whether you're talking about data engineering, data analysis, data science. Like, what do you mean data? Data interview. Yeah, maybe for some, I don't know, kind of special research scientist role, multivariate calculus would be standard. I'm having trouble picturing what job family that's to do with. But if you notice a pattern where the questions keep coming up and you keep flopping on them, then just backfill that skill on an as-needed basis. So this is in contrast to a mastery mindset. I don't want you to have a mastery mindset. I want you to have a sufficiency growth mindset. Sufficiency and growth. So you get to the point where you can start advocating for yourself, You go interview, and then if you have a bunch of interviews where you're getting asked a question and you just keep getting it wrong, on an as-needed basis, identify those gaps and fill in the gap. So those are the two things that I would have you do. One, distinguish between one-off weird situations that are definitely going to happen. Distinguish between that and patterns. And then if a pattern is a gap, fill it. Identify that skill gap and fill it on an as-needed basis. As opposed to trying to learn all of the things up front, learn enough that you can land interviews and then identify the gap. Does that make sense? Entry-level data science consultant. Yeah, entry-level data science is weird. Entry-level data science is weird. It's almost a contradiction in terms. So historically, data science, you needed to have like a graduate degree and preferably a PhD to get a data scientist role. And the bar has been kind of lowered to where you can find these like junior data scientist roles. There's just not many of them though. But that will be, yeah. The trade-off is that you can access the interview, but they're still going to be hard because they're going to expect you to have these graduate level skills. Again, we got these AI trainers, but let's ignore them. Here's data analyst. That's not the same. Where's like an actual junior data scientist? There's not a lot of these roles, but they do exist. Maybe I need to do data scientist in double quotes. This says mid-level data scientist. I still would be pretty surprised to get a calculus question. And it's just not a lot of roles, right? Junior AI engineer, that's not the same as a data scientist, huh? I don't know. I can't see. If I look through all the pages, I'll probably find a few. I would just say move on. This is like a small drop in the ocean of jobs. Like I would just say move on. I would not be particularly targeting junior data scientists. That feels like a bad move to me. Okay. Hey, quick reminder chat, check the link in my bio. Follow me on other platforms. TikTok is getting shut down.